Hello, and welcome to our skills video focusing on the whole design of our AOV Huron. My name is Kobe, and I'm a rising junior studying mechanical engineering, and I'm also one of the mechanical subteam co-leads for Machine RoboSub.
Hi, my name is Thomas. I'll be a junior come fall. I'm majoring in mechanical engineering and I'm the mechanical sub-team co-lead.
My name is Yuki, and I'm a rising sophomore studying mechanical engineering, and I worked on the torpedo launcher design.
My name is Annabelle Stronowski. I'm a rising junior in mechanical engineering, and this year on the team, I worked on design and development of the electronic chassis, as well as research for the gripper.
Our hull primarily consists of an aluminum frame, acrylic tube, and a 3D printed electronics chassis. Most of the frame is composed of thin 6061 aluminum plates that interface with the acrylic body and house our sub's electrical systems. The plates are assembled using marine grade epoxy and corner brackets. The rear plate contains penetrators, allowing electrical wiring to go from the dry internal environment to the wet external environment. The rear plate also contains extra holes where blank penetrators are for adding more external subsystems in the future. This way, we won't need to redesign and machine the rear plate every time we add to the sub. The bottom plate includes holes which are used for mounting a hydrophone, a downward facing camera, and slots which also serve as mounting points for other components, including torpedo launchers and weights. The front plate features an acrylic port for the stereo camera to see through. This plate can also be removed to access any internal components. The electronics chassis was 3D printed in order to allow for the more complicated geometries that were demanded by having to maximize the limited watertight volume available. This would have been more time consuming using other conventional manufacturing methods. Our first subsystem requirement was that the hull would be quick and easy to manufacture and assemble, which led to a simplistic yet functional design. We'll touch more on the reasons for that in a few minutes. Our next requirement was to have a watertight volume for housing our water-sensitive electronics. This was achieved using a face seal O-ring and a circumferential O-ring. We also needed the internal structure to constrain the electronics, battery, and stereo camera, which would prevent a dynamic center of mass while under operation. Lastly, we wanted our frame to have a lot of surface area with mounting holes and slots to allow for a design that would cooperate well with addition and changes of our design.
Because this is our first time competing in the RoboSub competition, we decided to focus on just 3 tasks, 2 of which are navigation-based. Those navigation tasks are the buoy and the gate. We chose to attempt these 2 tasks because their large software emphasis made them more manageable to address amidst COVID-19 restrictions. In addition, we developed a torpedo launcher system to attempt the torpedo task. We chose to attempt this task because multiple members owned 3D printers, allowing us to prototype various components remotely throughout the development process. We had also come up with a simple design concept for the launchers, which made manufacturing them seem more feasible. Because we were focusing on just 3 tasks to start, we designed our hull and our frame specifically to have modular capabilities. This way, we would be able to add additional mechanical systems related to other competition tasks in the future. In order to achieve this goal, we designed our frame to have a lot of free surface area, which means that there's plenty of room for other mechanical systems, and we made sure to include holes and other mounting points for these systems so that we wouldn't need to machine the frame anymore in the future. While the gate and the buoy tasks are largely software-based tasks, we are fairly confident in the sub's ability to complete them from a mechanical perspective and a hull perspective specifically. The frame of our hull was designed to accommodate a similar thruster configuration as the Blue Robotics' Blue ROV. This was helpful for the software team because they had used the Blue ROV to develop their algorithms, which made transitioning to a new sub easy from a software perspective. We did face some issues related to buoyancy control, which had made the sub more difficult to maneuver. These issues have been resolved, but it's possible that similar issues will arise again in the future, which is why we didn't give these tasks, the gate and the buoy, a higher confidence rating. From a mechanical perspective, we're also fairly confident in our sub's ability to complete the torpedo task because the fairly basic design of our torpedo launchers reduces the number of potential errors that may arise in the release. Our launch mechanism primarily consists of just a spring and a solenoid. We chose to use a spring in each launcher because they make the reloading process quick and easy, and we felt that they would improve the reliability of the launchers compared to other possible release methods that we considered, including pneumatics. In terms of our hull, we designed the frame such that the launchers would be very accessible, as they are located on the outside of the sub in an easy to reach location on the frame.
We made the hull design quite simple, but with rapid assembly capabilities to allow for more time testing. All the components were machined on a water jet since they only had constraints in the XY coordinates. Only corner brackets and bolts are needed to assemble the sub. We also decided to test corrosion of unanodized versus anodized aluminum to verify the importance of anodizing our finished AUV.
Our torpedo launcher went through multiple design iterations before we landed on a final design. The initial system was designed with our sole focus on the functionality of the launcher. 3D printers were used throughout the design process for quick prototyping, which helped us test our release mechanism and validate our design concept. However, because the initial focus was just on functionality, the system was relatively complex and not easily manufacturable. The new version of this torpedo launcher was developed in a way to increase the ease with which it could be manufactured. In this design, the barrel is split into two components, and a second snap ring was added as a replacement to the barrel end, which would have previously needed to be welded onto the barrel. Manufacturing was halfway completed, but was halted due to closure of the machine shop. We had planned to test underwater with all the manufactured and correct parts to measure the launch velocity and to look at the launch trajectory, which is important for the torpedo to hit the target.
When researching a design for our gripper, we looked at multiple possibilities and decided upon linear actuation. As you can see, the gripper will have a motor that spins a screw, opening and closing the gripper. Looking at this animation, you can see the different components of the gripper, as well as how it opens and closes. To begin our prototyping, we 3D printed several components of the gripper that are involved in the grasping mechanism. Moving forward, we will be prototyping multiple parts of the gripper and design tests so that we can see how much weight the gripper will hold. Also, we will be testing different adhesive rubbers on the contact points of the end effector for increased gripper ability. Due to the complexity of this type of mechanism, we're striving to achieve an isolated gripper system before we incorporate this system into the hull using the slots in the bottom plate.
Despite limitations on our ability to manufacture in person and restrictions on the machine shop related to COVID-19, we have been able to develop the whole of an AAV that is integral to the completion of the 3 competition tasks that we took on. And because the frame of our hull has modular capabilities, we have already laid the groundwork for next year's competition by having the ability to incorporate the gripper mechanism that we are currently developing. Thank you, and go Blue!